All right. I think maybe people are here. No, we have almost no one. Though my beautiful wife is in the chat, or she was, at least. what's this? So what I'm looking for now is I'm looking for where we have this pole lifty. Pole lifty. And this is probably, yeah, it's in the OS package. Right. Right. Hackers stream. That's what we're gonna call that one. Yeah, this one should be fine. Let's just call that FDs. So here we're gonna do some stuff. All right, so a brief introduction maybe to ProtoHackers, very useful website for those who might not know. Basically, it's a series of exercises for writing servers and so on. And so basically you go through these problems on the platform. So here, for example, you have these, some of them are solved, some of them are not solved by you, etc. And you have your own kind of status here, right? They range from basically the hello world of server applications, which is an echo server, right? So smoke test here is an echo server, right? It basically just echoes back whatever someone sent to it, right? So we should be able to verify this very easily ourselves as well, right? And basically the problems escalate somewhat, right, in difficulty. You have this prime server here that basically is each exercise will usually have some kind of thing that it's trying to, in some ways, focus on, right? In this particular case, we're receiving a textual format and parsing JSON from it, and so on. So this is a little bit about sort of putting essentially just your first set of business logic inside of the problem and so on. And if we look at the third one, let's see here, means to an end, we can see here that this is about having some kind of shared state or some persistent state across messages in some ways, and so on, because prime time here is not stateful, right? There's no actual state between requests. Means to an end is instead stateful, and we'll have this sort of some kind of data that a session will modify and so on and be able to ask questions about and so on, right? So they focus on slightly different things, and you know, successively it becomes a little bit more interesting, and so on, basically. And I have done a fair amount of these, not all of them, already before. I have done 0 to 5 here, mob in the middle. Speed Demon and past that I have not done yet. So as for what we're going to be doing now, well, presumably we'll get through the smoke test. One of the downsides of these exercises is that you actually have to have some kind of host computer that is accessible from the internet and so on. That will actually probably eat up some of our time today, right? I have access to servers that we can use and so on. So that's not necessarily a problem. But that will probably take some time, regardless. I do actually have an Odin compiler on a server that we could potentially use to build the programs on that server if we want. And we will see. Basically, we'll see what we end up doing. I also have some other solutions to these problems that we could be using. That could also be interesting to show on stream, to be clear. Are there any questions someone has before we kind of move forward? Probably not. All right. So basically every exercise will have some kind of a restriction, like you should be able to handle at least 5 simultaneous clients and so on, stuff like this. By the way, I should point out an echo server that handles only 1 client is just a few lines, but what they actually want you to do here is this is your first kind of, in some sense, like a template for a server that you can kind of set up, right? So it's, they want to kind of ensure that 1, you have a place to host this stuff or whatever. 2, you can handle at least a few clients at the same time, right? And they shouldn't be clobbering each other or, getting the wrong messages and so on, stuff like this, right? So that is basically kind of what's, going on in this particular exercise here, right? So let's see here. I'm going to just sort of write this code and then we'll see what happens. I will try to explain this kind of as we go. Task file. I don't remember actually. Hang on. Let's see if we can just copy some of this. Oh, okay. Right, we don't need any collection here, to be honest. We're not going to use any libraries, so it doesn't really make much sense that way. We're not going to use any of these. And here, I think we can just do this. 100 ms wait time. And here I'm probably going to say build smoke test actually, like this. And then we're gonna do smoke test here. And the CMD is going to be bin smoke test, like this. And here we're gonna pass CLI args like this. I think it's like this basically, at least. And the depths is gonna be build smoke test, of course, method none, silent true. Build smoke test here is going to build whatever we have in smoke test. We're gonna do all none debug like this. Opa. Smoke test like this. We don't have a collection, so that's out. The sources are actually going to be only smoke test like this, and this generates a smoke test binary. BST is our alias. Yeah, let's just do this. It doesn't matter so much, to be honest. These aliases actually, we can kind of remove them. We don't need them for the most part. here I'm going to remove this. We can remove this. We can actually remove the default task as well. Clean, we can keep, doesn't matter so much to be honest. No alias for this one. And yeah. This is our basic task file. And now if we run task smoke test, no write permissions for bin and kger bin. Undefined entry point, this is fine. Let's save this here. Here we actually need this. Undefined entry point, procedure main, smoke test. Let's do this by the way. Main is a proc, sure. I'm actually going to just do this by the way. Hang on. That's odd. Some kind of message. Let's see here. Build smoke test is build smoke test blah blah blah. Let's actually copy this and we actually want that. Undefined entry point procedure main. What am I doing here? That is bad. We are doing something. Odin run smoke test. Am I just sort of naming something wrong? What am I missing here? Someone fill me in, right? Main is a proc, as usual. I mean, nothing super interesting there. Am I somehow in the wrong folder? Like, what am I doing here? Odin run smoke test main file. Yeah, that works. Hang on. I'm missing something incredibly basic here. What are we even doing? Code Odin, unthread. I don't have sources, do I? Yeah, I do have sources, it's fine. This should all be fine. Is it kind of confusing? I've literally used this a ton. Undefined entry point procedure main. What are we doing here? Am I in some weird space where some of this has been changed? I mean, I've used the same Odin binary for days. Have I just found a bug, or is something just sort of, I'm missing something incredibly basic here? I don't understand this. Less code, Odin on threads. Main is a procedure. I mean, it's going to turn out to be something incredibly basic that I'm missing, obviously. This is always the case. No, the underscore doesn't, it shouldn't matter. There shouldn't be anything that affects this. Because I mean, we have this package name here. Yeah, we have a main in this one. What are we? I mean, certainly we could try that, but I don't know that that will be the actual issue. Even if it did work, right? So let's say we did this, right? And then we basically said, hey, Odin build smoke test like this, right? But this is probably, no. So hang on, smoke test. I was wondering if maybe this was a permissions error or something, right? Because it could be, but it's not. In that case, it wouldn't be able to read this file at all, right? What we could do here is we could say, for example, let's rename this, right? And then say this is now a smoke test, like this. And now suddenly this works. But underscores in package names are not a problem. So something clearly is fucked up. Let's exit this and oh, hang on. I'm pretty sure I know what is the problem. Let me copy some files and I'm gonna try to illustrate this. Some test. Opa. Does not match. Yeah, okay. So the real issue here is the underscore test. That's really the issue, right? So this is odd though, because if I just briefly take a look at, if we, for example, say less ProtoHackers, we can actually see here that smoke test exists here, but the file name is main Odin, because that's what I used back before I started doing the same name as the package name, right? So main Odin here will work, right? What we could do for this particular thing is we can essentially just say, okay, so be aware of this, right? If something ends in underscore test, you may want to just pick a different name, right? So in our particular case, we can just say, hey, server.odin is just the main file. That's where main resides, right? So now probably, if I had to guess, Odin build smoke test like this, right? It now works, right? So let's just call it server.odin. It's not super important. But if you use underscore test, that will just not work. It will work with literally all of the other names that we have, right? Because we can name them, you know. But yeah, this is a little bit of one of those leaky kind of abstractions where underscore test is like a specific kind of, it's handled a certain way, right? The file names, right? So even if your package name works, it won't actually work otherwise. Right, so now we're fine. Now if I do task smoke test, we should be fine, and we get loot, right? So that's all fine now. Let's comment this out. Okay, right. If port parsed. Yeah, we can do this OS RX1. We had some other error, listen socket declared but not used, sure. Cannot have value port of type, right. We need an endpoint here, and we can actually get the endpoint by putting together a few things. Net endpoint has two things, an address, which is net IP4 address is what we want. Though I think this is actually just an array, I want to say. We can also do net parse endpoint like this. Like this. And what we actually want to do here is just say endpoint dot port is equal to port, right? And here we want to just cast this u64 to int, which should be safe. And here we have a listen socket, and here we actually pass the endpoint that we have. And now we're fine. Now we have unused variables. That's what it's complaining about, basically. Let's see here. Cannot assign a type. Right. We don't need equals here at all. Of course, right? We just need to declare this. It will be zeroed out by default here. So there's no assignment happening at all. Okay. So I have this Unix here. That's not actually, I don't need this, I think. The thing we're going to be using is OS poll, like this. And we're going to pass these poll FDs to it, basically. And so on. And this is something we're doing because we want to basically have a set of sockets that we are listening to for possible action. Right, so this is an asynchronous mechanism, or well, supports that kind of thinking, right? So we're not going to be multi-threading anything in this particular example. We could do that for future ones, but we're going to just throw together like, oh, you can have 1024 possible clients at any one time here. We're not going to need that because we have a maximum of 5 that we need to support. But yeah, that's the idea. So we're going to be using this function with FDs like this. Right, we pass a slice, and here we can pass a timeout. I actually don't remember what the timeout is here, so let's actually go to the poll man page. Right, and so here we can see that the timeout is here, and this timeout will be, the timeout argument specifies the number of milliseconds that poll should block waiting for a file descriptor to become ready. Right. And here we actually kind of want listen FDs like this. And I'm going to just make that like this. And in this particular case, we can actually assign. So here I kind of want to just say listen socket like this. Hang on. No, hang on. Let's see. I just have to consult this for a little bit. Right, of course. Yeah. Right, okay. Actually, let's have this open there so we can sort of, we can go to it if we absolutely want to. So the idea here is, we actually want to put the listen socket in an FD, right? So an FD here, poll FD, is really just a structure, right? That, that contains a file descriptor. And when this goes through poll, basically what's going to be filled in is these two, right? And if they're filled in, we know, oh, there are events for that one, right? And so on. So what we could do here is we could keep this, and I'm going to try to do that, right? So we have 1024 possible poll FDs here that we could be using effectively here, with potential slots for sockets and so on. But what we could do also, which you saw I did in the other example here, is we could essentially just say FDs is a, and I'm going to do this now. So we have underscore FDs is a dynamic array, right, of OS poll FD, right? And we can start at 0, and we could have a capacity of 1024, right? And when you do this, what actually happens is you pre-allocate basically this, right? So here you can see length is the first argument here, after the actual type, right? And then you have capacity, and then you have an allocator, right? We don't really need to specify an allocator here, right? Because we're doing this at the top level. Basically, we're just saying allocate 1024 of these, right? What we actually get out of this is either an allocator error together with an array, or just the array and so on, right? So we would say allocation error here, or we can say poll FDs alloc error, like this. And of course, in this particular case, we can actually just say, if we fail to allocate this, obviously we don't want to start the server, right? Because we are before all of that stuff, basically. And FD will be our listen socket here. Events OS poll in for sure. Hang on. Do we need Unix here? Yeah, it's not in OS. I might actually need sys Unix. Yeah, so we need sys Unix here in order to specify this poll in here. This could be moved to the OS package. It would be entirely reasonable to do this, I guess, but regardless, at this very point, we're using it from sys Unix. It's possible that it actually exists somewhere else. So if we take a brief look here, poll in might have a definition, right? You can see here that it exists in WS2, right? And so the reason you might find that this is the case, right? So if we go to WS2, this is WinSock, right? WinSock 2, which is based on BSD sockets, right? In essence, it's just an implementation of BSD sockets, right? So you can see here, for example, a WSA poll FD is suspiciously much, like the poll FD that we have, right? You can see here also that they have these poll in, which means basically we're going to poll for incoming things, right? And so on. And yeah, so WinSock is basically a re-implementation of BSD sockets, right? So this is why all of the platforms actually mirror BSD sockets, because at some point Microsoft decided to effectively re-implement this interface, right? Because before that, they actually didn't have this at all. This is a while ago, though. I don't remember when Microsoft did this, but I do think it was actually, I mean, I guess it's always had its quirks, so I wouldn't be surprised if someone came here and said like, oh, by the way, they don't actually implement it 100% fully. But generally speaking, that's basically what they're doing, right? There are a few key things, maybe like, oh, we have to initialize WinSock and in different ways and so on, right? So for example, you had this WSA startup call and so on. But then you do have poll, which is basically what we're using, right? And you can see here that we have a this array of FDs, right? File descriptors, these poll FDs, right? And then how many we have, and then a timeout, which is exactly the thing we have, right? So WinSock is really just sort of that, right? In the end. Like I said, though, wouldn't be surprised to find out that no, there are these small differences that just annoy people, right? Because there's a little bit of a Microsoft thing in the long, you know, like this is sort of how it turns out usually. Anyway, that's completely beside this point, to be clear. But yeah, just a brief detour. So here we actually want this more than anything. And the poll second argument was a timeout, which we could just say, you know, I don't know, 25, doesn't matter. These are milliseconds, so. And this will give us, hang on, what does actually? Don't remember what the return value is. Sure, okay. Right, so we only really need to check for negative numbers, right? Poll result, and then we had, what did we have? Poll error, like this. Yeah. I'm gonna say no. And you might wonder, like, is it fatal to not be able to poll? I mean, it does suggest that something is fucked up, to be clear, right? And here actually we want listen FDs like this, to be honest, because we want to listen for, hey, is there an incoming connection? This is actually a number here, so we can output this as a number. You would want to humanize that, but bleh, to be honest. It is generally speaking better to just check for specific ones if you're interested in handling them, right? But yeah, you do want, if you have user-facing errors or something like this, you definitely want to humanize these. For us, it doesn't really matter so much right now, though. I'm going to reuse poll result, actually. Yeah, we're gonna do that basically twice, right? If poll result is equal to 0, I mean, no, we don't need to check that at all. If the poll result is greater than 0, we do want to actually accept connections or whatever. for FD in, oh no, actually, we only have one here. We could just say let accept TCP listen socket client socket accept error like this. And here we could basically say if accept error is not nil. This one is a little bit of a stretch, I would say. Here we're gonna do log also instead. And we're gonna set up a logger at the start of the program, right? So context logger log create, not file logger, console logger. So file logging, by the way, is very useful. You can use it to great effect. Especially in tests, if you want to log a certain test case. I have one project where I log all of the instances of something happening, and if the test succeeds, I remove the file. If it fails, we keep the file. So then you can just go in, and when a test fails, you can just say, test has failed, what was the actual output, right? And you don't need to have your screen get spammed with stuff, because these are not console loggers, they're just file loggers, right? Very useful way to do this. Log, though, I should say, impacts performance a lot, especially if you write to files, right? So, you know, be careful with this, because it really kills performance. So if you're trying to get something out of your tests in terms of like, oh, we can tell how fast it is. No, you're not going to do that with that scheme at all, right? So that's something to keep in mind. Let's see here. We have accepted a socket here, and if we couldn't do this here, if we fail to accept a client, we kind of just want to jump out. Yeah, let's just do this though. And here we actually want log, like that's why I added this log error f. And we don't need new lines, by the way, for log, so you're aware of this. Let's see here, we have accepted this, and now we actually want to say fd poll fd is equal to os poll fd like this. And we want to append to our FDs the poll FD that we just created, like this. That should be fine. Now we've accepted a client, like we're listening now for the accept once every iteration, basically, right? So if there is a message coming in or a client that wants to connect, every loop here, we will first check that, right? To handle any incoming clients of just like, oh, I want to connect. And then what we're going to do is say poll result, poll erno with our FDs, right? And so here, I suppose we could do, I mean, 10. I don't know that the timeout is going to matter much, right? And if the, sure, again, we want to kind of fail if something, you know, doesn't work or whatever. Here we could just say continue, to be honest, log error f, like this. Continue, of course, is going to go to the next loop in the for, right? If something happens here. And this is only because like the entire poll result is wrong, right? It's not for an individual thing, right? So if, oof, oh, that's a lot of code. We're not gonna, we're not gonna accept all of that. Wow. Copilot, slow down a little bit. So if the poll result is above 0, that means we actually have file descriptors, right? That are ready to do stuff, just so we're clear, right? If it's 0, it means everything is fine, but no one wanted to talk to us, right, basically. And if it's above 0, that means at least someone has wanted to say something, right? So what we're going to do now is just walk through all of those, right? So for FD in FD's this slice here, this should be fine. At least I think so. If FD are events and Unix polling, I'll explain this. So our events here, we can actually look at the. So requested events, right, was what we filled in the beginning. I'm interested in things coming in, poll in, right? Returned events is basically which things have action here, right? So what we're doing here is we're saying if the FD in question has our events and masked, this is going back to the bit masking episode, right? If we mask with Unix polling, we are requesting exactly that bit in the events, right? If that's not 0, that means there was something set in that bit, right? We want to do stuff, right? Because that means something came in. And we're looping through all of the FDs here, to be clear, right? That means potentially 1024, right? Which won't be an issue though, to be clear. And now we can receive data, right? So here I can say net receive TCP, right? And FD here. FD because this FD is a poll FD and that has an FD field, right? And here we want to receive this to a buffer. So what we can actually do here is we can say there is a receive buffer like this, and this can be for 96 bytes. I think that the messages are actually not going to be above that, but we're gonna see here. It doesn't say, but we can probably tell. So here we can actually say receive buffer like this, right? This takes a slice. And if we can say here bytes received is going to be 0, and then we can say n, so let's say 255 here. 4 bytes received is not 0. N is declared but not used, that's fine. And here, what we can do is basically, let's see here. There are a few scenarios here, right? We can receive 0 bytes, basically. So just to be clear, receive, it returns how many bytes we received, right? And if we receive 0 bytes, this actually means that the connection is closed, right? So here what we can do is effectively we can say bytes received equals n here. And if we receive something, to be clear, we are going to send that back to the client. Right, so we're going to say here net send TCP to the FD in question, right? And we're going to send exactly this, right? Receive buffer up until n, right? Because we received n bytes, right? So we're going to send that back. Right? This is what an echo server does. it echoes back to you what you sent it, right? So let's see here. If the event unit component, etc., etc., etc. We're going through all of the FDs here. That's fine, and so on. And here, actually, what we can do, let's just sort of, hang on. When we accept, I'm going to set an option, actually. We can do set blocking, actually. But what I wanted to actually say here is this one. And it's not actually this, it's socket option dot receive timeout. And well, no, we don't need to do this, right? We don't need to do that really, because okay, we don't. Okay, I'm gonna skip this for now. We will want this at some point, though. Just saying. Here we are FDFD type I32 to TCP socket. Sure, we can actually do a net TCP socket like this, because we know what this is supposed to be, so it's kind of fine. Now, if someone missed this from yesterday, an FD is a file descriptor. A socket is really just a file descriptor, which is a number. So if we go actually to net TCP socket, we'll see that this is a distinct socket, right? Distinct is a way to basically say that the underlying type is the thing on the right, but for the purposes of type safety, this is its own type. So I can't just pass a socket where something is expecting a TCP socket. Likewise, I can't pass an I64 where something is expecting a socket, right? This means basically that we can have functions that return these types that we then can use, for example, and so on. Or we can cast them to say, this is definitely this, by the way, right? But we have to be clear about it, so it's much more verbose in some sense, right? This also means you can't actually confuse a TCP socket with a UDP socket, right? So we get some level of very, very, very cheap type safety, and this has no runtime cost, right? These are not, structures that have some kind of thing around them, right? They don't cost anything. So, yeah, a socket is really just a number, right? Which is also what, for example, a file descriptor when you open a file is. At the end, or in the end, like most OS resources like this in certain operating systems are just numbers. Those numbers are handles into usually a process-specific table, right? So for example, we might have a program that wants to open a file, right? So it says to our operating system, I want to open a file, right? And we open the file, everything's fine. What we get back is a number, right? That's our file descriptor. That number is not somehow unique in the OS, right? It's not a global number. I can't pass that to another program and then it can use this number, right? Instead, what usually happens with resources and so on is that a process will basically have its own table of these things, generally speaking, right? Just like actually memory is, right? Of course, there is in some sense, a global memory, right? But memory from one process doesn't necessarily correspond to memory from another process, right? But pointers, interestingly, right, are just numbers as well, right? They're just handles into different tables at the end of the day, right? So most of these things are actually kind of the same as each other in the end, right? So a socket, in terms of what we're passing around, we're just passing around some number that represents some kind of thing, some resource, right? In our case, it's a handle for some kind of connection, right? Oh, this is cint. Never mind. We should be able to just say i32 here maybe. Because the cint is i32, I think. Let's try, let's see that, right? So what we can actually do here is we can import core libc. I think it's libc like this. No. Core c libc. C declared but not used, that's fine. So now, presumably, if we go to where I used i32, we could say c int, right? Libc int, what is a libc int? It is a c int, which is a i32, right? So this would have been fine to just say this is an i32 here, right? But what we can do is we can say c int here as well. Assignment count mismatched. Yes, that's because there is an endpoint argument here actually. Client endpoint, if I remember correctly. We can go check this here. Yeah. So the source here will be the endpoint, you know. I think that should be it. We can ignore that for now though. Cannot assign value client socket type to TCP socket to i32. Right, and again, we can just say cint here, right? They're all castable between each other. We just have to be specific about it, right? This is kind of like implicit conversions and explicit conversions, right? In C++, right? You can mark, for example, a constructor as being, you can only use this constructor specifically, for example, for conversions, right? And stuff like this. So it's distinct types are neat in that they kind of force you to actually say, yes, this is what I mean, right? And you can't just say, for example, oh, we have a socket. Well, is it TCP or UDP, right? If you have a UDP socket, don't use that with accept TCP. Like, this is not going to be doable, right? So as an example, if we tried that, let's try it. I might be completely wrong, but I think it's a good bet, right? And here, of course, it's saying you can't pass a UDP socket to a TCP socket, right? That's just not doable. Even though these things are the same type under the hood, right? It's not possible. So that's it. I'll be honest, haven't really checked a lot of stuff right now. We're probably dead wrong here, but so what we can do here, it's been a while since I used netcat here actually. Netcat. Okay, NC. I can never remember the options for netcat, by the way. You'll have to forgive me here. I'm going to be fucking around with this. Let's see here. Let's just do NC. Okay, we're not handling multiple clients. We're definitely not. What are we doing then? We're doing something stupid somewhere. Let's see. Gonna quit these as well. Actually, do we need this timeout that I was thinking about setting? Probably. Or is it more like, no, why am I checking bytes received? Right, that would probably be more it, to be honest. Let's just do this. By the way, this needs to be checked, of course. Bytes written. And what we can do here is, let's just say bytes sent, rather, right? This is 0 from the beginning, and then 4 bytes sent is less than bytes, or n here. We could just name this bytes received, like this. Bytes received, like this. While that's the case, we know that we haven't sent all of the content, right? So here we can just say n and send error, like this. If send error is not nil, we want to, sure, we can break, it's fine. And then we actually want to say bytes sent plus equals n, right? And that should be probably it. Like this. Oh, what am I doing? Why am I starting it? Oppa, hello. There. How are, okay. So now we have multiple clients ostensibly at the same time. They don't seem to be getting each other's messages. That's nice. They're sending secrets and so on. Any questions, by the way? I mean, the chat is very quiet. I'm assuming people are just sort of having it on in the background. But if there's any questions that sort of pop up here, I don't want to pretend that all of this is super obvious stuff. And I'm trying to explain some of it, of course. But, you know, it's not always super easy. But is there anything that sort of feels like, hey, I am wondering about this thing, potentially? It's fine if nothing is, you know, unclear or whatever. So now, by the way, I'm just checking my servers a little bit just to see which one I could just sort of connect to and so on. Because I have a few. A couple, I should say. that I use every now and then. Let's see here. I have one actually that's just sort of sitting. Actually, I will show this. This is from a web server I made actually in Zig, which I don't know. I don't have any timestamps, as you can see, but this was a while ago. I will tell you. The uptime is 1,213 days. So you know we can only assume that's somewhere in between there. I was doing this. But yeah, this was an interesting thing actually. Let's see, we don't have any, like I said, we don't have any timestamps here, right? But yeah, this HTTP server is made entirely in, like from scratch, right? And I used to host my website actually with this web server. It was very fast, actually. But there was an interesting thing that happened. You can see HTOP on the side here, right? And there was an interesting thing with this because if you this web server ran in I think less than a meg of memory, right? Actually, far less than a meg, I guess, right? Let's see. If I go to Tools, HTTP server, we can run it and see. Actually, what are these question marks? What's happening there? That's a little bit weird. Anyway, HTTP server, right? What did I run this with before? Sudo HTTP server. Yeah, let's do 20. And here, by the way, I probably have a special password, by the way, for this. Right, now the server is running. And you can see here that the reserved space is 200 bytes. I'm going to try to connect to this. To be honest, I don't remember what the IP is, but let's see if I can find it just real quick. Hang on, let's keep that open there. By the way, I'm trusting you guys not to do anything weird, okay? Just wanna, I'm gonna try this and we'll see what happens here. Right, so now I've made a request. And you can see actually one of the posts here is from 29/07/2020. I was burnt out on Haskell at the time. Right, and yeah, this is basically everything here, to be honest, is basically, that's how I feel now, still. This is really cool, by the way. Also a cute lion. It's not a lion, of course, but you know. Anyway, so we've now made some requests, right? What happened here? How much memory are we using? We are using 264 bytes. Still, that's what we have reserved, right? But then there was a thing that happened when I was doing this that sort of, it was so depressing somehow, right? Because if you look at this machine, you'll realize fairly quickly, at least it was the case at the time. Now I actually can't really find this anymore. But there was this interesting process that ran Python that like chewed up like 35 megs of memory for no fucking reason, right? And it's just like, I've made this web server, right? That is reasonably fast. Fast is not really the point necessarily, right? But it takes no memory. It uses as much of the stack as it can, and so on. It's so careful and so on. But then you get this reboot script made in Python that just sits and chews through everything, right? Oh no, hang on. By the way, no, I'm wrong here. It's we're using 4 kilobytes. I'm very sorry. Anyway, it's not a lot though. But the point being, we are basically out, competed in some ways by everything else, right? Where this whole thing, right? It doesn't really, yeah. You're always going to have something that just sort of eats up your computer regardless, right? You can make these things that just use nothing and whatever. And to be fair, I mean, this is not necessarily your typical use case, right? If you I wouldn't necessarily recommend writing your own web server and being like, oh, this is hyper optimized necessarily, unless you have an actual use case for it. This was mostly one of those things. I just wanted to do it. And it sort of just happened, Anyway, it was fun. I'm probably going to do the same thing in Odin, probably going to make some videos out of it because it's interesting, it's fun. We do the live stream yesterday was obviously, right, we started doing effectively this, right? So if we go to the HTTP client, this has now turned into an HTTP server, right? Server. I have not committed this maybe, hang on. Right. Yeah, this has now started, becoming a server, and we did some basic sort of parsing of the incoming messages just to see like, hey, there are requests coming in, what do they contain? So we have this parse message function that returns a message, which is a path and some headers and so on. And this is going to come together and become basically the same thing as the web server in Zig. Probably. I mean, I can only assume. What is going on with my terminal on that side? Right. Yeah. I was looking at this morning. This is not made for the stream. It's too wide. Anyway, I sidetracked just very drastically here. Anyway, this was fun. We're not going to use that though, like this. And I'm not entirely sure we're going to use this machine. We're going to try my other machine, this one, because I have Odin on this machine. So we can use the Odin compiler. It's not the current version, to be clear. Yeah, here you actually have this. Yeah. Right, yeah. We could just empty out this entire thing. Maybe. Probably not. We're gonna just make a new thing. mkdir ProtoHackers stream. Like this. Bam. There you go. What is this? We compiled Odin. Git pull. Fuck off. What? Why did I get this message? For some reason. It's fine. Let's not think about it too much. Oh, I'm using LLVM 13 here. That's a while ago. I mean, not for me. This machine actually I used this not that long ago, to be honest, for Odin. But I think it's just that I didn't have anything except LLVM 13 at the time. We're gonna use that and see what happens. I mean, it's probably not gonna matter anyway. But now we're building an up-to-date version of Odin, right? So we might actually just have a later one, right? You can see here 23.11, right? So this is all now fine. We can basically use that. And here we're going to git clone some stuff. So we should prepare for this already, basically. Yeah, let's starting smoke test, fuck off, git init, I'm gonna quit here actually and say git add smoke test, Odin format, all this, and task file. Remove the bins, and here we actually want a git ignore for sure, like this. And here we want everything with bin. We want bin, the actual folder, like this. We can see here, what are we doing here? We can ignore task, like this. And we can remove some test, to be honest, right? We don't need that folder to be here. We were just fucking around with the whole name thing, right? And now, yeah. I think that's it. Let's commit some stuff. Ah, I don't have task. Well, that's annoying actually. Do I have ASDF maybe? I do have ASDF, thank you. Hang on, plug in add task. Beautiful. Ah, I do have auto completion, that's so nice. Technology, huh? Right? Sometimes technology is not so bad actually. That's not the version we want. I've been bamboozled. We actually want 329. 330, 331, yeah. 31 is what we want. Yeah. This autocomplete, the fact that it's alphabetical, right, it really fucks with you. We're gonna install this one. And now we do have task. We can do ASDF global task 331.0 like this. And now we can actually go in here and say task something, right? So for example, we could be doing just task HTTP server, right? I don't have autocomplete for this, I guess. That's annoying, but not. No, hang on, task. I do have no, I don't. I'm so sad. Task smoke test rather, with the arguments for this one. No write permissions for output path. Yeah, sure. Okay, there bin. Right, so now we have the smoke test on port 4201. I'm assuming this is the same IP actually. We can see. It will just time out if we can't connect. Which it seems like we are not able to. What was this IP? This is the IP for the other box. Yeah. And again, I'm trusting you guys to not do anything untoward. No, actually, I don't know that there's a lot running on these machines. If someone were to break into them, I don't think anything happens. There's nothing interesting on them anyway. Curl ipconfig. I just have to find the website. Ifconfig me, maybe. Is that one? No. Yeah, this is the IP 140.8233.12. 8233.12, yeah. Port 4201. Why am I not allowing connections? Am I starting it on the correct port? I mean, I should be. Right? Let's see. Yeah, I mean, the port is undoubtedly the port we are getting from the command line, right? So 4201 should be fine. Did I connect to the wrong one here? No, 4201. This is why it's good to have a smoke test, by the way, right? Because this is basically what allows you to find these problems with this stuff, right? Once you've solved that, it's not, going to be an issue. Right. So because I want to verify this, I'm going to actually go to a different. Oh, hang on. Yeah, I'm in a different directory. Anyway, we're gonna go to inbox here. We're gonna do smoke test. Like this. Connected. So this one is obviously connected. So it's not the configuration of the server. We know that much. Though it's taking a suspicious amount of time just sitting here now. So of course there could be something with our firewall or whatever. Probably not though. It wouldn't be able to connect if that was the case. We should actually see output here. I'm surprised it's not saying anything, because this process usually does not take a lot of time. So it's almost like something is timing out here, right? When something is taking a long time like this, I always suspect that, okay, something is timing out. So we're waiting 30 seconds, something like this, right? This is an old binary built, by the way, with older Odin. Yeah, timeout, right? Timeout after 60 seconds. So clearly, something going on there, right? And lots of output. Lots and lots of output. God damn. Slow down. Just a little bit. I'm going to, hang on. I'm just going to check which port this is running on and so on. Oh, hang on. I know what the problem is. It's good that I checked this source. That's good. Let's fix that problem. Well, I think I know what the problem is. You should never say you know until you actually knew. But here, yeah. This makes so much sense. let's do this. We don't need parse endpoint. Honestly, we probably should have just filled in the endpoint ourselves and so on here, but whatever, it doesn't matter so much, to be honest. Here we're gonna just say fix rather, bind on all interfaces in smoke test, right? This is why you have a smoke test, right? So for those who might not know, when you bind on 0, what you're actually doing here is you're binding on all interfaces. When you're binding on 127.0.0.1 and so on, you're binding only on your loopback interface. And your loopback interface is only accessible from your computer, right? Not even your network, right? 127.0.0.1 is really just sort of yeah, I'm binding on this particular, like we can test it locally effectively, right? But 0 binds on all of them and so on. So that would be the issue, I'm assuming. We can of course just test this hypothesis, it's not super hard. We do a git pull, we do a Odin build, let's see here, task smoke tests, like this. Try again. Of course, this doesn't mean that it actually works, but it means that, you know, we can see it's now connected, right? So now we have actually, we have bound on all of our interfaces, right? But yeah, we're timing out here, it seems. We haven't added any logging at all, so we don't know anything about what's going on. I don't remember the tests that they have either, because they have some tests and so on. Well, what we're gonna do now is we're gonna log when someone connects. Let's do that while this is failing, because I'm assuming it is. So now, let me just sort of double check some stuff while I'm checking this. So here, what we actually can do now is we can say client endpoint, actually, and say if there was no error, we actually want to log infof, right? And this is not going to be S, it's going to be V, right? Like this. And we could make this a debugf, it doesn't really matter so much, to be honest. Presumably we will actually remove it. Let's do debugf, right? And we can also say like, hey, maybe we're gonna log how many clients are actually connecting and so on. That could also be a useful thing. Or rather, how many clients have something to send, for example. Let's do log debugf poll result like this. Actually, let's do if poll result is greater than 0, right? Because that at least will indicate that, yeah, we do have multiple things here going on. Let's add this. For accepting clients and poll. Like this. Yeah, we have 1 constantly. We just have that. It's basically what's going on. Right, so we accept 1 client. Right. And then we just get poll result 1 because presumably we're not actually handling much of anything. Let's see. Right, so we are obviously we're past this point here, right? We're getting to this point. We can see that we only accepted one client, right? Meaning this section here consistently then basically this poll result here is it's just 0 here, right? But here it consistently returns 1, right? So clearly we are not handling this client, right? We are always trying to receive from it, which is a little bit odd, isn't it? I'm going to just raise that number there. I don't know that it matters though, to be clear. I do have a test suite actually written in Elixir for some of these things we could actually be using. But let's not do that yet. If fd, revent, and Unix poll in is not 0, right? That logic is fine, right? Right. I'm now printing this in hex. I don't know exactly what the value should be, but we can reasonably easy just see here that right, we should be seeing basically 1. If we don't, there's something else going on. Right, there's something bad, right? Let's see here, receive TCP, sure, we're receiving this into receive buffer, which is currently this large. I'm assuming the first message that's being sent is not going to be, you know, we could of course say here, right, 8 mem kilobytes. You know, something like this we could do, right? But I think it's odd though. I think it's a little bit odd that the previous smoke test version also failed. That seems a little bit strange somehow, right? Maybe I'm wrong, I don't know. Debug. What did I add? I added the debug if for So I don't use this model of development very often, right? Where I commit a bunch of debug stuff, obviously. This is mostly when we're obviously building this on a remote host. And I basically have to get the content over there somehow. And of course you could say, hey, just send binaries, right? And I would, right? Except if you build Odin on, for example, Arch Linux, like I use, right? And then you have this Ubuntu box or whatever it might be, your libc is not going to be the one you need, and so on. You're going to get an error there, right? And so on. So it's not good that way. Right, so our events is 0, 1. Right. Obviously I'm doing something wrong here. And we need to, obviously, I'm missing something, right? In terms of maybe clearing something here. No, maybe not. We saw, obviously in the local test, we saw that this worked, right? So that's a little bit, as in we received content back, right? This means what's going on is probably something else. Let's log what we're receiving. Right. Yeah, let's try that. So received is receive buffer like this, and log debug if blah 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 like this. Seems fine. And here we actually want to say basically this same thing. Hang on, there is a bug here, by the way. We actually need bytes sent when that is less than bytes received. We actually need basically this. We never saw this, of course, in our testing because we didn't have messages that were long enough. I'm not 100% sure that that will actually be 100% correct, but it's difficult to try right now. Let's see here. Add debug log for received and sent messages. Actually, here I forgot to add this. Oh, passed content 0, right? So one test passed, okay. That means the fix I did now probably worked for case number 1. And then of course we received 0 bytes, which is a timeout or a disconnect rather. Right? And so what we want to do here is going to be if bytes received equal to 0, sure, this. And here we actually want delete from this. This should be fine. Nope. Hang on. Delete. I don't remember if this is delete slice. No, that's not the thing. So we have this FDs. We have an FD that we are currently looking at, obviously. Is this a number? Let's pass this and see. Right, because, so what I'm looking for here, by the way, is if we go to odinlang.org, we'll see in the overview, for example, right? Dynamic array. Append, inject at, assign at, and so on. Remove. Ordered remove. Unordered remove. Unordered remove removes an element at a specific index. Unordered means it is O1 since it swaps the last element to the removed location, making the array be sorted differently. I don't know that that matters. Well, no, it matters because we're modifying it while it's being used, so that would be bad. We could mark it for removal, change it, you know, after, but let's not do that. Let's do an ordered remove. Like this, and the index we're going to use is actually going to be here. I think this is the one that's swapped. FD index is what I'm going to call this. I suspect it's this one, but let's see. And this ordered remove doesn't return anything. And that's fine. So here you can see the reason I'm talking about, oh, this is swapped or whatever, is when you iterate through a slice, right? For example, let's say you have a map, 4kV in map, in M, right? The key, right, is on the left side. The V, right, the value, right? You kind of expect this here as well, right? The reason though, I suspect, I seem to remember, the reason for the order here really is iterating through the keys is deemed more common here. Likewise, of course, iterating through the thing in a slice is deemed more common. So that's the one you're going to have alone most of the time, basically, right? So that's why they're on the left side. But it is, in some sense, counterintuitive to have the index on the right side, right? Here. But that is basically the reason. So the FD index here is an int, right? That is the actual index of the thing. Hang on, let me double check that though, because remember we are actually dealing with ints here. Now I'm actually, no, FD is an entire poll FD. So this has to be correct. Like if I try to switch this around now, we should see there's a compilation error, right? So that's fine. We're good. Let's see here. Let's see here. We could also say net close here. I don't know that we have to. I mean, certainly we don't have to, but let's see. Fix remove connections on client close. By the way, in many of these cases, you'll find that people instead say peer here. That's because you have host and peer, right? Which is server and client. right? So if you have ever seen like peer closed connection and so on, that is basically what's going on. Like, but this host and peer is relative to us effectively, right? We are essentially the host, they are the peer, right? So, though I realize now most of you know what peer-to-peer is, right? So I don't know why I even added this. There you go. All right, so now we've passed the smoke test, and this of course took 5 years. But what we have actually set up for now, of course, is to do the rest of these, right? The smoke test in itself is just a way to get going. Right now, we have confirmed that yes, we have some sense of what's going on, right? We've solved the absolute most basic problem, right, of the whole thing, right? And I feel like an idiot asking this again, but any questions about any of this? Anything that comes to mind? You know? Like I said, I don't know why I ask, but yeah. I have to just move a little bit. I will be right back. I would love for some questions to be in the chat when I get back, but I understand if you will not at the same time. Anyway, be right back. All right, I'm back. Sort of off topic, but want to know if you know a way of accessing values inside of a bit set. I know you can use in to something. The reason I'm saying something here, by the way, is because I'll show you this. So this was down there, right? You can use in to test if the value is inside. Yeah. Yeah, I'm sorry. So no, not really. I haven't really used bit sets very much, if I'm being completely honest. So I wouldn't necessarily know. Yeah, let's check if we can find something, right? I mean, this is basically the only bit sets. Yeah, using sets was efficient for solving them. Yeah, I don't know actually. Like I said, I haven't used them very much, to be honest, so I don't really have. So, want to know if you knew a way of accessing values inside of a bit set. So you mean like values parentheses, basically, like all of them, right? Actually, yeah, in an array you cannot use an index to access a certain value, right? No, not really. I mean, I don't know anything, and I'm kind of not really finding anything here for this either, right? Because these to me don't necessarily seem to be even the same kind of thing, right? But, and I'm not really finding like, hey, for either, right? You could do that somehow, or yeah. But yeah, I haven't used them a lot, so I'm sorry, but I don't really have a lot of ideas. I don't want to misrepresent this, right? Because I mean, the risk here is that I'm just sort of making shit up, right? And I can't really find anything. So that seems. Yeah, I end up using a loop, using in to return. Yeah, okay. This is basically kind of what I was thinking about, right? But yeah. Actually, what do we have if we look here in the collections? Container. No. Yeah, in most of these cases, obviously, I would just sort of. Actually, hang on. Yeah, we don't have a specific set, right, at all. But basically what we actually would have in some sense, right, is effectively, actually, is this possible? Let me just double check here. Some set is a map of string to, it's auto-completing for me, but we'll see. Void here, we can't have that. Actually, what can we have? Can we have C void? Like, is that a... Because we don't really have a void type necessarily, right? Yeah, this is not a type. Oh, hang on. I haven't thought about this. But you can't actually have void inside of a map either, right? Because void has no space, right? What you could do here is you could effectively have struct, right? Yeah, okay, you can do this. This also doesn't take up any space. Hang on, I've done this before. Yeah. Hang on. I've done this before, but what I did was basically I named it void. It's an empty struct, and then I did something like this at some point. Right. So you have a set is really just a map from whatever your value, your key type is, right? For example, right? We could have ints, we could have strings, we could have our cool type here, right? And then the actual value for that key is nothing, right? So that way you actually get a set in terms of semantics, right? Now I'm not saying this is necessarily like the most efficient way of doing this, to be clear, right? But it's certainly doable. And then you get basically, okay, now our map stuff actually works for this thing. I'm not gonna 100% say that, oh, this will work just fine, but I'm gonna say 90%. I would try it, to be honest, right? Because, well, yeah, I think it will probably work. And maps are actually reasonably good in Odin, as far as I know. They store, for example, keys and values in different areas and so on, which of course doesn't matter here, right? But in some languages, you'll find that what actually happens is that a map is equal to KV, for example, like this, right? Which is of course completely illogical, right? It's only logical if you think about it as KV pairs, right? But the key to using a map is usually that you want a map to be key, and so on, right? Like this. And then when you have found that a key exists, you want to actually look this up in some list of values. We want to basically be able to go through this very efficiently, right? In order to check for existence and stuff like this, and not have the value be loaded in memory, right, in the cache when we are looking through the keys, for example, or we're doing something with the keys, for example, right? These don't actually need to be stored together with the values at all, right? And it is a comparatively rare operation to have to get the value, right? And even if you were to get the values, in many cases, you're actually iterating through those values as well. And you only want to iterate through the values, not the keys, for example, right? So it's very tempting from like a semantic standpoint to think about this in terms of key and value pairs, right? And store them together. But this is of course completely inefficient and makes very little sense, right? So you want to basically store them separately for many use cases. Certainly as a default setting for a map, we probably don't want them together at the very least. I don't know if that makes sense. I'm kind of rambling obviously, but yeah. As far as I know, sets in Odin are pretty well made. All right, I think it's probably not worth it to start on the next exercise today. I will continue with this tomorrow though. And we're actually gonna, because now we passed the smoke test, right? So we know everything is set up correctly. What actually will happen now is that we take this code, right? And we look at, okay, what are the different parts of this, right? So today I will basically continue by going through this code and explaining what I'm thinking here, right? Tomorrow, what we're gonna do is we're gonna move on to prime time. Very likely we're also gonna do means to an end in the same stream, right? Because we've done the part where we just set up the server and all of these things, right? So we've kind of cleared out some of the details here. And then we're gonna continue and so on and so forth. So tomorrow we're gonna do more exercises, and what I'll do now before we end the stream is just go through this one to explain what I'm kind of doing, right? And I'm gonna go ahead and assume that we don't necessarily wonder here what a logger is, right? Context.logger. We parse the port. That's not really a big deal either. The interesting part comes here. So we have listen TCP here, right? This is the actual setting up of the server. And the reason this is only one call, right, is because listen TCP actually does several things. You can see here in the implementation, listen TCP does the actual stuff that needs to be done in the background, right? So here, what actually happens is that it first figures out hang on, what is this again? I want to say address family, but endpoint family is what they're saying here. But okay, yeah, address family. This is just basically, this should be AF INET in most of these cases. Let's see. Yeah, INET, this one. Address family INET is how you would specify this usually, and so on. So this is just, you know, internet protocol, I suppose, is what you would say. Then we create a TCP socket. We do this with this socket call here, right? This is normal standard BSD socket interface, right? So socket creates this file descriptor that we were talking about, and stream here is actually TCP actually. And we create this with AF INET here, stream, and then we choose protocol here. Is the last one, and here we set sock opt. This is probably the most common mistake, I would say. Like every time I made a server ever, I've made this mistake. It's not a huge mistake, you're not gonna, you know, suffer for it, but this option here, reuse addr, you want probably for your development. You definitely want this because you're gonna be restarting your server over and over. If you don't have this socket option, what actually happens is when your program quits for some reason and it has bound to an address, right? You're gonna find that this will it will be busy basically when you try to, you know, call your program again. What we do then is that we bind, right? And this takes our previous socket, right? We establish the socket, we set an option on it, right? And it binds to the address that we created before, right? This here. This is basically your 127.0.0.1, etc., right? In our case, 0.0.0.0, and so on. Then we listen, right? And that's why this call is called listen TCP, because it ends here basically with listen. And listening is actually the thing. Here we're telling the operating system, I want you to map a port to my process, right? So ports, again, are just a number, right? But ports are global, right? If someone is using a port, we can't use that port, for example, right? So we are saying bind this port to my process. We're telling, in our case, Linux, this port, when something comes in on this port, I want you to send it to me, basically. That's what bind does. Listen here is basically setting us up for actually receiving the connections, right? If we didn't have our listen call, we would have no way of actually doing this, right? So we're setting our socket now to be actually actively listening on this socket, right? And backlog here is basically how many entries can be waiting to be accepted at any one time. If backlog is too small or whatever, we won't have anyone who is able to wait at a certain point. So in some sense, this provides back pressure, right? Meaning we are not accepting connections fast enough. There's a bunch that just want to be connecting, right? So it can be a good thing or a bad thing, right? So all of this happens inside of listen TCP, right? And we're calling listen TCP here, right, with our endpoint and so on. And that's why we only need one call. But this is actually 3 separate calls to things, right? And you'll find these, by the way. So if anyone needs this resource, hang on. Do I not have this open? I thought I prepared for this. If someone needs to read some of this stuff, one very good resource is Beej's Guide to Network Programming, right? This focuses entirely on C, but all of this is valuable to learn regardless for you. Right? You're using Odin, but it doesn't matter. Here you'll find basically, you know, a bunch of information about different things, certainly more than we've talked about now. But here you'll find these calls, right? So socket, bind, connect, listen, accept, etc. All of these things, right? You can learn about them, right? So this is a good resource. I'm gonna post this in the chat if someone needs this. You all need this. Everyone needs this in their lives. I don't care if you've read it before. Just, you know, just do it. Anyway, so we are calling listen TCP, and this is doing all of those things, right? This gives us a listen socket, is what I've called this here, and yeah, whatever. It's just a socket. It's the one that we are actually receiving connections on, right? And then I'm setting up this underscore FDs here. These are just file descriptors, right? For this poll FD thing. I'm gonna talk about this a little bit more. We also set up a poll FD for our listen socket. So we have a set of poll FDs for that one, separate. And we say basically, I want to listen for incoming events on this set, right? We set up a receive buffer. This is entirely on the stack, of course, in our case here. And then we say, we poll, and here we have a for loop here, which is this is a never-ending loop, right? We don't, do we even have a break? We have a break for this for, but we don't have a break at all. Everything is just happening over and over and over, right? So here I'm calling poll, right? And poll might be unknown, but if we look, for example, in Beej's stuff, we will probably find here poll. Poll, by the way, is old. If I don't think that you should necessarily use poll in practice. You should use ePoll or IOUring. Interestingly, IOUring can often be slower. So, but yeah, the mechanism at play here though is the actual important part, right? So when you have a bunch of sockets, right? So you have clients effectively, right? You're setting up a server and you have a client or multiple clients. Not all of those clients are going to have messages for us at all times, right? We do want to handle all of them, right? So what poll actually allows us to do is basically give a whole set of sockets and just say, fill in the ones that actually have data for me right now, right? Or fill in the ones that are ready to receive, for example. That's also a use case you can have, right? What this actually means is that we can just say, bam, here are all of the poll FDs in this case, right? Just fill in the ones that are ready. I'm gonna loop through all of them and just see, are you ready? If you're ready, I'm gonna receive from you, and then we're gonna do the thing, and then I'm moving on, right? So none of this is multi-threaded or anything interesting like this, right? It is entirely a mechanism only for saying, I have a bunch of sockets I want to give you, just fill in the ones that are ready, and I'm gonna actually do something with them, right? That is the actual mechanism. And this works also for ePoll, right? So ePoll is a modern alternative to poll. An even older alternative is select, which I actually used back in the day. We can actually look at select here. So select it works sort of in the same way. You can see here we have a number of FDs. We have an FD set for read FDs. We have an FD set for write FDs, and then accept FDs. And then we have a timeout, basically. You have to use these functions, FD set and so on and so forth, clear is set, and so on and so forth. It's a little bit of a different interface, but it accomplishes the exact same thing as poll and epoll at the end of the day. It is even older and possibly slower than poll, though. But yeah, this is basically how they used to do stuff. And honestly, it's entirely feasible to do this for lots of servers, even nowadays, right? Poll and select, however, don't necessarily scale very well. But just today, I actually, let's see here, epoll IO uring. I found a comparison between IO uring and epoll because I was a little bit curious, because IO uring is effectively a much more modern interface of basically storing some kind of, let's say, getting back effectively a vector or whatever from the OS of events and so on, or supplying a vector, a list, an array, or whatever you want to call it, to the OS, and the OS fills in this vector for you, basically. And then you can process events that way and so on. Much more modern interface. And curiously though, if we look at this benchmark, because this person was interested in sort of, had heard that, oh, IO uring is slower than epoll sometimes, or just plain slower, right? And an interesting thing here is that in these tests, right, they've tried different buffer sizes and so on, and seen sort of how these things kind of move, right? And you can see here actually that in terms of both throughput and queries per second, right, epoll actually wins out, interestingly enough, right? And epoll does not have a limit on how many file descriptors or whatever you can have either, right? So it's not necessarily that's the case either. But uring is certainly, uring is a much more modern interface, much more certainly hip, or whatever you want to call it. If anything in Linux can be hip, I'm not entirely sure. But yeah, and their conclusion here is uring is slower than epoll in the streaming mode. When buffer size increases, the performance gap is drawing near, right? So you can see here that the difference is not so large when buffer size, meaning the received size of messages and so on, grows and so on, right? But yeah, it's an interesting thing, this. Yeah, I'm curious a little bit about sort of what you should be doing in C, for example. It is, I kind of feel like maybe epoll is one of those things where it's good enough for the vast amount of workloads, to be honest. If I was writing a, let's say, high user server, I would not necessarily be using C. I am curious to do it in Odin though. Normally speaking, I would just use Erlang for this, because it has characteristics that just are perfect for servers, generally speaking, right? But yeah, this is an interesting thing. Also, by the way, we don't have epoll in Odin. So if we look here, we search for epoll, we will find that the syscalls are there, right? In the syscall modules, right? So the actual definitions of the syscalls, because I don't know, maybe people don't necessarily know this. Syscalls are really just kind of these numbers here, represent basically, you execute a syscall function with a certain number that represents a particular syscall that you then have, passed arguments to beforehand and so on. That's basically how this works. Oversimplified, of course. And we have these numbers, right, for these, but we don't have the actual functions, right? So we don't see anything in OS Linux, for example. So we would have to add that, right? Because if, for example, we have poll like this, right? So if we go here and hang, just, yeah, we have poll because I had added poll. And so what you actually would need to do here is you would have to do the corresponding thing for epoll, as I've done here for poll. You would just do Unix sys epoll, etc., and so on, right? Because if we go here, we find that there are no interface functions for those either, but we would have to create them basically, right? So we would say, you know, return int very likely blah 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 with sys, you know, syscall sys epoll create and so on, stuff like this, right? So we would have to do this basically if we want to support epoll, which I do think we want. So I will probably make a patch at some point for this, very likely. But yeah, okay. So then we have our poll FDs, we have our receive buffer set up. We're polling here, which we went through now, right? We're giving a set of FDs. If the poll result for our first poll check is yes, we know that we need to accept something, right? And we know we only have one client or one listen socket, so we just say, hey, the listen socket must be ready, accept on it, right? And then we accept the client, right? And we can see here, the output, of course, is a bunch of stuff. We can see maybe that this message should show up at some point, though. I think some of the tests are just sending garbage, to be honest. Okay, we're probably not going to find this, to be honest. I suspect here that we're not. Yeah, they are sending a lot of stuff. So they're sending multiple 8K chunks, by the way. So anyway, we accept the client here and we add it to our FDs, right? So when we have accepted a client, we then add that to the set of clients we want to listen for, right? So that's our underscore FDs here, right? And then we poll those clients, right? We poll that set, right? And we say, if any of them are, you know, interested in talking to us here, right? We want to loop through, right, each of them and just check, do this basic check here. This basic check here says effectively has has something to send to us, effectively. Poll in for us, right? So we ask, do you have anything for me? This particular one. We don't ask them because we're basically asking just the structure the poll has filled in. Because remember, poll here fills in the FD's structure, right? The poll FD structure is basically just a, bit pattern of, yeah, I have stuff to send, I have stuff I want to receive or whatever. These kinds of things. And then we do know here in this if they did have stuff that they want to send. So we do receive, right? We pass the FD in question. We receive into our receive buffer, and here I'm using the slicing syntax because the receive buffer is actually an array, right? But I'm just slicing into it, basically. And if we didn't receive any bytes, that means the client is closed, has closed the connection. So we remove that one from our FDs, like this. And then we close the connection, but this honestly might not really be needed. And then at this point, if we did actually receive something, of course, we will not break here. We will slice into the receive buffer exactly how much we actually received, right? And say we received this many and so on. And also what did we receive, right? And then because this is an echo server, we are then just saying, oh, I'm gonna send everything I received back, right? So the send slice in question here is going to be however much we've sent so far until how much we received. And of course we loop here because as long as we haven't sent enough, right? We haven't sent as much as we received, we're gonna be doing this, right? And send TCP here returns how many characters or bytes we sent. We say, oh, we sent that many. And then we add it to byte sent. At some point, this, of course, this up here will return true and we will just pass, right? So we're going on to the next FD here. So with that walkthrough done, I think we're done for tonight. Tomorrow we're gonna do, like I said, we're gonna do prime time, means to an end, maybe budget chat if we have time. And basically the smoke test here was perhaps the longest one because we have to figure out just the absolute basics. We have to just set up the server and all kinds of stuff, right? So yeah, that's the plan. And yeah, I hope you'll show up tomorrow for the same thing. Have a nice evening and ciao.